Hello, everybody. Welcome back to another episode of Server Room. I'm Nandini, your host for the podcast, and today we have Malini, who is the head of LATAM for the Research and Development Division of Zoho Corp. So, welcome to the show, Malini. How are you doing today?
Thank you so much for having me. I'm doing good. How are you?
I'm doing really well. It's a pleasure to have you on the show,
Pleasure's all mine.
considering we've had a shared history of working together as well. And so, how did AI come into your life?
Quite by accident, actually.
Okay.
I was recruited right out of college through the campus recruitment program, and Zoho is my first job.
Okay.
So I didn't have any idea that I was going to get into AI. I was actually recruited into another product team called Alarms One. I was there
Okay.
for 3 months and then they had to downsize the team. So I was by chance
Mm-hmm.
moved from Alarms One to Zoho Labs. And that
Okay.
was my introduction to AI.
Okay. And
I'd
which
say paid.
college? Okay. Which college was this?
I did my BE in computer science in SSN College of Engineering.
Okay. Done. And why BE?
Why BE? Okay. So I come from a typical family where your parents want you to be either a doctor or an engineer. Yeah, and medicine was not something that I wanted to go into, so I decided engineering. But then the choice of picking computer science as my major, that happened primarily because I was exposed to coding in the 11th and 12th grade, and that was something that I liked, or rather, maybe I'm a bit lazy because I found it to be very easy for me. So I picked that easier path rather than do something that I thought was hard, like easy.
Okay. And is it still easy today as well? With all of, the innovations coming about, I think day after day.
It's certainly not what I expected, I would say. I mean, you got to constantly keep upskilling yourself. There's always something new to learn.
Right. Yeah.
And especially in the field of AI, when you have a lot of these innovations coming in at such a quick pace, um, it's important to keep yourself updated about everything that's going on. So, yeah, no, I wouldn't say it's easy.
Okay, okay. So, how do you keep yourself abreast? Like, it's very difficult considering the age we are in right now, because every hour, I think you have some notification popping up on your phone saying that this is launched, that is launched, this can be possible, that can be possible with Gen AI. So, how do you keep yourself updated with all of it?
I don't try to, stay on top of everything per
Okay,
se.
okay,
I try to, keep my focus on certain areas that I'm interested in or certain areas or technologies that I think would be useful to the kind of use cases that
right.
we're working on. So
Okay.
that sort of helps me separate out, all of the noise that you sometimes see. And a lot of these trendy things that come up, they're mostly just fads that sometimes, fade out over time. So it is quite hard to, try to figure out which technology is here to stay and which is just a current fad. Um, so yeah, I'd like to, see how these technologies develop over time to get an idea of if they're actually something that it's worth investing your time in to learn or pick up that skill.
Okay. So you mentioned about use cases that you currently work on. Can you just touch upon what exactly you're working on today?
Today I am working with multiple teams, both in Manage Engine as well as Zoho Corp. Mostly time series analytics related use cases, things like anomaly detection, forecasting, more of the traditional ML stuff and not necessarily the GenAI side of things.
Okay, okay.
User and entity behavior analysis, which you could say would feature in the cybersecurity side of things.
Yeah.
Fraudulent transaction detection for our finance suite.
Right, right. Yeah.
Even reinforcement learning.
Hmm?
Um,
Okay. Is
yeah,
it
my
production
team.
ready? Can I ask you that?
No, it's still far away
Okay,
from
okay.
production. But yeah. So
Okay.
yeah, I have a team that's actually working on applying reinforcement learning to optimizing databases.
Okay, okay. Because when I was working on ML use cases, RL was part of the scene, but I couldn't really figure out how to apply it like practically. So is has that trajectory changed, or is it like is it something you're still
It's not
working?
applicable for most of the use cases that we typically see in the enterprise. Maybe that is why we didn't actually look into it much.
Okay,
But there is research being done about RL, particularly in the field of robotics.
okay, okay.
And obviously the usual gaming side of things. But most recently, ever since LLMs have come in, RL is now being used to train
Train.
these LLMs. So
Okay.
that's where most people use RL now.
Okay, okay, done. Okay, I think we've gotten too in depth, but I just want to ask you this very preliminary question about what exactly is Gen AI. And we also talked about ML versus AI, and you said that you're working on the traditional ML techniques. So maybe just a little bit about what's the difference between AI and ML, if you can.
Okay.
Yeah.
So AI is more of, I would say, a very broad concept. So AI would just any system that could mimic human intelligence would come under AI.
Okay, okay,
Okay. Whereas machine learning is a subset, it's a set of techniques wherein the algorithm or the model is able to learn or derive insights from data.
okay, okay.
Okay. And how these two relate is ML is a subset of AI.
Right.
AI could consist of other things as well, okay, other than ML. To give you an example, maybe take a self driving car.
Okay.
Okay. So that is an AI system.
Hmm.
So when the car is driving, it learns to recognize different objects around it,
Yeah.
different traffic signs, the traffic lights.
Correct.
So all of that is being done by specific ML algorithms that are trained to recognize these objects from data.
Okay, okay.
Okay.
Hmm.
But now when I see that the light is red,
Hmm.
okay, what should the car do? It should stop. And when it's green, it's supposed to, go
Accelerate.
forward,
Yeah.
accelerate. So how do I teach the car this behavior? Sure, you could probably run simulations and train the car where it learns that if you see the green light, you're supposed to go, and if you see the red light, you're supposed to stop. But the simplest way would be to just put in a few lines of code that says, if the light is red, just stop, right? So, not everything needs to be learned from data. Some of it um, could be codified as rules,
Right,
right?
right. Yeah.
It's equivalent to bringing in domain knowledge, the knowledge you have about these traffic systems, about traffic signs. What do you do when you see this particular sign? See, all of that, it's a lot simpler and more accurate for you to just codify these as rules.
Correct, huh?
And this would still constitute an AI system because at the end of the day, the system is still exhibiting intelligent behavior, right?
Yeah.
It's not necessarily learning stuff from just data. So AI systems could be a mix of ML algorithms that are specifically learning or deriving some insights from data. It could be a mixture of all of these rules that are imbibed. You could even search algorithms come under AI. Search algorithms are basically trying to find an optimal path from a start point to a goal.
Yeah.
So all of these systems together still come under AI. So I would say AI is a very pretty broad concept, and ML is a subset of AI. Now, when I come to Gen AI, that, as the term suggests, it refers to a subset of algorithms or models
Okay.
that are able to generate new content.
Okay.
And this content could be in the form of text, it could be code, it could be images, video, audio, anything, any kind of new content.
Okay.
Okay. So again, Gen AI models are also machine learning models because they are trained based on some data, but they're able to use that data to combine certain aspects of this data to generate new output.
Okay.
Okay.
Okay. All right.
So if you were to draw a Venn diagram, it would be AI, and then ML is a circle within it, and Gen AI is a circle within ML.
Okay, that's a lot of circles, but okay. All right. So, if I were to build a Gen AI model, what do I start with?
Obviously, the first thing you would need is data, massive amounts of data, maybe the order of trillions of tokens, right? So that would depend on the size of the model that you want to train.
Right.
Okay, and it's not just about collecting this data. This data also needs to be pre-processed. Okay, so what does this pre-processing involve? You should make sure that there's no data duplication. You should remove stuff like, personally identifiable information. You should make sure that any bias that you see is eliminated. By bias, I mean racial bias, sexual bias, any kind of bias that needs to be eliminated. And when you're scraping data from the internet, right, publicly available data, you do end up with data that could be toxic in nature, that has a lot of hate speech, that promotes violence. So all of that needs to be scrubbed out as well. So data collection is one thing, but then it is a major process to sort of clean this data. So once you clean the data, um, actually coming up with the model architecture, that is another decision that needs to be made. So are you creating like a general purpose model, or is this model going to be for a particular domain? If it's for a particular domain, then you would need more data corresponding
To
to
that
that
domain, yeah.
domain. Yeah, so and then how big is your model going to be? And once you decide on that, next is the infrastructure part of things.
Right.
So when it comes to the infrastructure, unlike, much smaller traditional ML models, this would need a huge number of GPUs, hundreds, if not thousands of GPUs. So this isn't like, training the model just on one GPU that was usually done for smaller neural networks. Now you'll have to find a way to parallelize this training across maybe thousands of GPUs.
Okay. Okay.
So that is another challenge. How do you your entire data pipeline needs to be parallelized so that the training can happen in parallel.
Okay.
And again, monitoring this training is another issue. So this training could happen for days or weeks, and you need to constantly keep monitoring the training loss to see if there is any instability in the training,
Okay. Okay.
which we typically would not do for much smaller models because you would probably train that in 4 hours or so. And it's not that expensive to, retrain it if something goes wrong. But here, retraining from scratch would cost a lot. So you can imagine thousands of GPUs and you've run it for days, and then you find out that there is some issue with the training, or the training is unstable for some reason. So then you need to start all the way back from scratch, or go back to the point where it was stable, right? So in order to, avoid starting from scratch, you would need to constantly monitor this training to make sure it's always stable. And if it's unstable, stop it as soon as possible so that you can revert back to the earliest stable state.
So can you do that? Like, can you pause the training and then go back to the latest stable version?
That would be possible if you had logging mechanisms in place
So
where
that
you're
would,
constantly, yeah, you need all of these tools
uh,
to make sure you're able to debug, to make sure you're able to log models or
mm,
checkpoint these models at different intervals.
okay,
So all of
okay.
those tools need to be built into
Mm-hmm.
your, data pipeline
Mm.
so that you're able to actually train this model.
So that would require an additional storage space as well.
Exactly.
Okay, okay. So, you mentioned about cleaning your pre-processing data. In that, you mentioned about how you need to get rid of data which might be biased towards anything. But I have a question. So I used to think this data that we actually take to train any model is the previous or the past year's data. Okay, so if let's say today I'm going to train a model for XYZ reason, like for a particular reason, I am going to probably take data from T minus 5 years, right? So that data already has a lot of bias involved, which in the case of employment is most of the people who are employed are going to be men.
Yeah.
And their opinions are going to be actually logged. And that's the data I'm actually taking to actually train my model. So, how do we get rid of this? I don't think we're ever going to get rid of it because only in the recent past have, women actually gone vocal about how they actually want to work. So, today we are two women here. But I don't think we can definitely get rid of all of this bias at all.
I mean, it is a very tough job to actually, especially when you're considering that you're probably talking about, billions or trillions of tokens in your
Right,
data.
yeah.
Which is why sometimes the bias does creep through, because it is a very, very tough problem to try to get rid of all this bias. So there are examples of some companies where, you know, um, I think in the past, one of the tech companies, not mentioning any names, but yeah, they had a recruitment tool that they wanted to use. Yeah. And then this bias that you were talking about was very apparent there. So, because they trained this tool on resumes submitted, and they found that most of those resumes were male, the algorithm understood that to be that females are not preferred candidates. Yeah. Okay, so this led to a huge issue, obviously, when they figured it out. So, um, at that point, what can you do? I mean, you could try to even out the data set by, undersampling the male resumes and oversampling the female candidates resumes. But that is a very simple case for a simpler, model
Correct.
classifier. Yeah, it's easier when you're working with a lot less data to identify these sort of biases and find a way to get around them. But yeah, when you're talking about data of this size and magnitude, it's inevitable that bias sometimes creeps through. So if you cannot capture this in training, what you would need to do is try to have robust evaluation tests where you check for this bias. And then you find a way in post training to somehow remove this.
Okay, okay. Done. Is that going to be costly as well? Like post training, if you do want to go back to retrain the model?
Post training is mostly okay. So you could even call it fine tuning. So then you sort of, with a much smaller subset of data. So just to handle those edge cases or to remove bias or any cases where the model is not working as expected. So it's a much smaller subset of well curated data that you then used to train the model. So this is nowhere close to as expensive as the actual training of the model would be.
Okay, okay, done. So I'm sure there's a lot of math involved in all of this that we talked about. So classification, then pre-training. I think at every step there is a lot of math involved. So how important is it for you to actually be sure of the basics with which you're actually dealing you're training your net model with?
Well, I would say that depends on exactly what you're trying to do. If you're a researcher working on active areas of research in Gen AI, then it's obvious that you need to know all of the math behind it. Okay. But if you're just attempting to train a Gen AI model from scratch, I think it's enough if you just know the basics of
Okay.
how the network is working, exactly what happens, but you don't need to delve too much into the math
Okay.
because this is more of an experimentation kind of thing rather than something that actually needs mathematical knowledge. If you have it, then great. But if you don't, I don't think it's that big a deal.
Okay.
So you might need it. Maybe it might become easier for you to debug certain things if you were aware of the intricacies behind. But then you could just as easily solve it with experimentation or other methods where you are aware of the purpose of the method, you're aware what it's going to do, what you're using it for, but you don't necessarily need to know the math behind it or every step that is happening in the background because the frameworks that the deep learning frameworks that we have anyway abstract all of that.
Right, right.
And if you're just going to be using an already trained LLM and adapting it to some use case, then I don't think you need
Yeah.
any mathematical knowledge at all. So it really depends.
Okay, done. So, if you were to hire a candidate today, if you were, okay, if you were to hire a candidate today, what would you look at? Like, would you pay more attention to his math skills, or would you actually look at the prompts they put into an AI model?
Um,
You can take your time.
Today. Okay, so it basically depends on the role, right? Like, what kind of use cases do I see this person working on?
Right.
Um, I don't even need to know that they have all of mathematical knowledge, that they're thorough with, that they're well versed in linear algebra or probability or statistics or any of the mathematical theories. I just need to know that they have an aptitude for it.
Okay. Makes
That
sense.
when they do see some equations come up occasionally, they're not going to run away from it. They're still able to, it shouldn't scare them. That's all. So we just look for like a basic mathematical aptitude, I would say. And yeah, unless you're into research, I don't think you need that level of expertise in linear algebra or calculus. So just a basic mathematical aptitude would do.
Mm-hmm. All right.
Um, and prompt generation, I feel it's more of an art, I would say, than a science.
Okay.
And I think you would only improve in that area the more you actually work with these models and understand them.
Right.
It's
Yeah.
not a well defined science per
Okay,
se.
okay. But is prompt generation very important in the domain of coding, or is it more prominent in, let's say, a more creative domain, like let's say marketing or probably something else?
Your prompt always matters, okay, in whatever domain you're using the LLM for, because differently worded prompts can sometimes generate very different results. So you need to experiment and find out what the right prompt that you need to give is. So
Okay.
I don't think it really depends on the domain per se.
Okay. Okay. Done. All right. So, with a lot of agents coming up these days, it's very easy for anybody to start a company themselves. So,
Mhm.
just a single person company, and they're actually building products, they're shipping it, they're getting users. So, how do you, so vibe coding is another buzzword that is coming up in this space. So, what are your thoughts about this?
I feel like vibe coding is a bit of a paradox, to be honest.
Okay.
Um, so vibe coding is basically using your LLM to generate code, and you just provide it requirements in natural language,
Yeah.
right? So when you have the LLM generating code for you, naturally the expectation is that your productivity improves, right?
Yeah.
And you would think that among software engineers or developers, the people who would benefit most from this would be freshers or developers who do not really have that much experience. But I don't think that is what is happening.
Okay.
I feel that the productivity is maximized only with senior developers.
Okay.
Let me tell you why. Because when you go to the AI system and you ask for some code, especially for it to do something like build an app, sure, it may be able to generate the app depending on how complex the application is. And it may, work as a POC,
Yeah.
but I do not think that they are production grade ready, right? Because your prompt, your basic prompt that you're giving it, will not necessarily cover all of the edge cases or the issues that you would actually see in production.
Right.
So this works great for a simple POC, for very simple applications, particularly for boilerplate code, right? So I would say that they're great for when you don't want to be writing all of this boilerplate code that you would anyway find on the internet, right? Stuff that you would have googled and copy pasted anyway, right? These would be able to generate algorithms, data structures. Those are all readily available, so you could use um, LLMs to generate that kind of code that does not change much. It's exactly what you would need, right? But when your code requires a lot of customization, that's when these issues pop up. So when you're like a junior developer who does not have much experience, first of all, you don't really think about those edge cases. You might have thought of it if you had to code it yourself, but then you just accept the code that the LLM is given as is. Maybe you would run it for some generic test cases and it would pass, and then you would assume that it is bug free. As a junior developer, you're not going to go spend the time actually sitting and reading through the code to figure out whether it is actually what you wanted, right? Whereas a senior developer, I feel, would have better knowledge.
Okay.
It's they're going to be able to decipher that code a lot faster
Yeah.
than a junior developer would. And they're going to definitely bake in all of those edge cases, add those edge cases themselves. So I feel like actually the people who benefit from this are senior developers who could have actually written that code on their own, except now they're generating it, but they still know
What's
what that
actually
code
going on?
would do.
Yeah.
And they know how to catch bugs. They know how to incorporate all of these edge case handling.
Yeah.
Um, Basically because they're very good debuggers. If
Right.
if
Yeah.
you're a, if you've had enough experience as a developer, you naturally become good at debugging and at understanding other people's code, which is not the case for a junior developer.
Yeah, yeah. Okay. So, what are your thoughts about the one person company then?
Well, it might work, provided he is a pretty good developer himself and he is able to catch all of this. Like I said, there definitely is a productivity gain, but it's all about how we are going to use it. A good developer would know exactly which cases to use the LLM and in which cases it's better to just write the code himself.
Okay, okay.
You would also know how to structure your code. It would be better if you could break down your use case or problem into smaller sub problems that are easier to debug
Yeah,
when
yeah.
you're giving it to the LLM rather than just ask it for the whole code. Then it becomes a lot harder to debug,
Right.
a lot harder to manage. And these are some things that I feel that, good developers would automatically know. They just intrinsically know how to query, how to debug. And that's not something a junior developer would have any experience with.
Yeah, yeah. So, have you used AI agents? Have you played around with them?
AI agents? No, I haven't had a specific use case in mind per se. I mean, the usual LLMs per se work well to my use case. So, are you asking about the coding aspect or?
Yeah. Like if let's say you want to automate anything, I mean, it could not be work related. It could
Yeah,
be,
yeah, I'm saying that's why I'm talking about all of this. So I have found that it does generate a lot of bugs that are hard to catch, especially if you're giving it, um, if you're asking it to generate a lot of code instead of breaking it into these individual parts, like I said. And sometimes, even for me, it becomes hard to, decipher that code. So I can imagine how much time it would take a junior developer to actually do. So I would use it more to generate test cases, a lot of test cases. It's good at that. It's good at, right, like I said, generating boilerplate code. Extremely good for developing, POC applications where you're not actually intending to put that into production without, a proper review of the code.
okay. So V0 is when you actually go to your LLM. Perfect, perfect. So do you look at AI agents becoming teammates in the workplace or
Yeah, I think that is the goal. I mean, they're becoming increasingly important in the AI system, and rightfully so. Um, because I just see a lot of potential for these AI agents
okay?
uh, in terms of increasing productivity across different sectors,
Yeah.
right? So think of the service sector. I could have an agent work as an L1 level, customer support agent. Um, Maybe think of education. Think of a tutor agent who is able to tutor kids individually according to their needs, right? um, Medicine, and medicine, think of an assistant to the doctor that's constantly following up on patients, reminding them to take their meds, asking them about symptoms, or automatically booking doctor appointments for them. uh, think of finance. Okay, you could be your personal finance, an agent that could go through your personal finances and then tell you where you need to stop spending or how you should save, and that could be done at a company wide level as well. So like I said, even legal, like you could have an agent that is reading through all of these legal contracts and summarizing them, and letting you ask it questions about the contract,
Yeah.
throwing up any weird clauses, anomalous clauses that it usually does not see, or potentially problematic clauses that you might have missed if you had to read through like a 45-page contract, right? So as you can see, they're all completely different domains, but these agents do have use in all of them. So there is a lot of potential, yes. So I think, yes, that is where we're heading, and that is the goal. to try to incorporate these agents is maybe um, digital employees, perhaps. But of course, there are issues with that. Number one being, how do you trust this agent, right? So, AI again is not deterministic.
Yeah.
um, you can't always guarantee that it's going to do the right thing. Okay, it could be a highly accurate model, but there are going to be some cases where it's going to make a mistake. So it really depends on the use case. Is that mistake okay?
Yeah.
Or, and typically, if it's a human employee, humans also make mistakes, but they typically learn from their mistakes, right? So is this agent able to learn from its mistake? Is it able to remember all of its past actions? So you know now that LLMs have a very particular context length, okay, that they can actually remember, and that is fixed, varies from model to model. But agents would need to have persistent, long-term memory to remember all of the actions that they've taken in the past. And humans typically learn over time. The more they do the job, the better at it they get. And again, you would want your AI agent also to learn as time goes by. So, and that's when reinforcement learning again comes in. This memory persistence also comes into play there. So again, another issue, explainability. Like, right, you're going to be able to trust an agent to do a task only if it's able to explain why it did so and so actions, explains its thought processes. So that's another thing we have to work on.
What level is it at right now? Do you think it's okay or it still needs improvement?
I think it still needs improvement. I
Okay.
mean, I personally would not have an agent put into any critical tasks right now.
Okay.
Something like customer support, that should be fine, right? You have a knowledge base to back you up, and if there are any issues, you always have the L1 agent could automatically escalate it to a higher level. So
That's,
things like
yeah.
that is fine. I could even have an AI research agent which basically crawls the web for a particular, if you want to research about a particular topic, it brings you all of these papers, summarizes them. So all of that are not critical use cases, right? So for those kind of use cases, it's perfectly fine
Yeah.
to have an agent. um but yeah, anything critical, I think it would still need uh, a lot of improvement.
So, you mentioned about issues with AI agents, and I think a lot of these issues also revolve around privacy because we mentioned about how we can use it for our own finance advisor. So, you will have to put in some numbers there to actually show the LLM that, this is the numbers you can work with and this is what I want. So, I think there is a lot of these edge cases where you don't know where you're drawing the line, whether this is, information that you wanted to know or whether it's information that is just going to be taken as a general input. So, where I think there's a lot of these issues, and I think laws in general these days as well, they're not very stern about a few things. So I think everybody is just playing catch up in terms of all of this because I think legal issues, I think, are still going to be a huge issue. So, like, what do you think about all of this?
As far as, putting in your own data to agents or LLMs, um, I think the companies, if you're using a third party service, then
Yeah.
obviously your data is going into their, servers. But they usually do have a disclaimer about what they're going to be doing with your data. And then at that point, it's the individual's choice, and the liability lies fully with you. Um, So yes, I think if you use the free version of ChatGPT, they do warn you. There is a
Yeah, yeah, yeah.
disclaimer that the data you enter could actually be used by OpenAI for training. But whereas if you're integrating ChatGPT in the enterprise version, yeah, so they clearly state that privacy policies clearly state that your org data, your enterprise data, the entire organization, none of it will be used by them for any training. So your data is supposedly secure.
Yeah, yeah.
I think that's pretty much all we can expect. If you really want your data to be super secure, then the only way, at least from an enterprise point of view, is to run these LLMs yourself within your own data center. Okay. Even if you're hosting these LLMs in other data centers, like a self-hosted LLM or an LLM that you have trained yourself, if you do not have the infrastructure to host it or a data center for your organization, you would still be hosting it in AWS and other, third-party data centers. And again, there is the problem of this data, leaving your organization. But that issue exists even with all of the other products that you use,
Yeah,
right?
yeah.
So at some point, you would have to trust that the vendor's privacy policies,
Yeah.
that they do follow whatever they've stated. So you only have privacy, total privacy, if you're actually hosting these models within a data center that you own yourself.
Right. Yeah.
So at Zoho, at least, our privacy policy, I think we do guarantee it, especially for our the internal self-hosted LLMs that we have. We do guarantee it at both a user level and at an org level. When I say at an org level, I mean that the organization obviously owns all of its own data, but any models that have been trained using this org's data are also owned by that organization. So, meaning no other organization, we do not allow other organizations to access this model that is being trained on
Okay,
one
okay.
particular org's data.
Got it.
And at the same time, you will need all of these privilege access management at a user level, right? I cannot access another employee's data. So I should not be able to query an org wide LLM and ask for somebody else's payslip data. It should not return results.
Yeah.
If I query it about my payslip data, it should be able to, provide those results, but not somebody else's, right? So that access management, even at an individual user level, all of that needs to be baked into your
LLM.
pipeline,
Okay,
right?
okay.
To make sure that the LLM only has access to data that it's supposed to have access to.
Okay, okay. All right. Are these based out of tokens? Like for each user, there would be some unique token, right? Or
No, it's not at a token level. It's more like you, before the prompt even goes to the LLM, like you verify access, right? So when the prompt goes to the LLM would probably, okay, if I'm asking for my payslip for this month, so the LLM has to basically figure out, or the agent that you're talking to has to figure out that if it's payslip information, I need to go to Zoho Payroll, access Zoho Payroll's database,
okay,
and I need to provide this person's details,
okay,
right?
okay,
At that point, so when it generates those plans, that is where you would need to make sure to step in and verify that I am generating data.
okay.
I mean, sorry, I am accessing data from Zoho Payroll, only data that belongs to me.
Okay, okay.
So you would already have access tokens, right, to when you're accessing Zoho Payroll on your own. So those same access tokens apply here as well.
Okay,
Okay, so it's just an API that is being exposed to the LLM.
okay.
So you would need to provide the same credentials that you would when you access Zoho Payroll application, even here
Okay.
for
Okay.
the LLM to be able to sort of access that data and provide it to you. So the security is sort of built in that
Right.
way.
Yeah. 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 Yeah, I don't think an LLM would be able to generate such a huge model on its own. There would definitely be like a senior, as you said, there would be a senior developer who would be involved.
No, so this is in the agentic framework. Okay, so when I'm talking about agents, there are different components. Okay, so the LLM acts as a sort of like a brain of the system. So it is able to understand your instructions or your prompt, and it's able to plan and decide,
Yeah.
okay, this is what I need to do in order to fulfill this task.
Okay. Okay.
Okay,
Okay.
that's just one part of an agent. So you also have other parts to it, like what are the actions that this agent can perform. Those actions need to be defined beforehand. Okay, you don't give the agent free rein to everything, you need to limit its scope. Okay, so if, for example, this is an AI research agent, what actions can this agent perform? What tools does it have access to? So obviously it needs to go access the web, right? It needs to find a way to surf the web. So you provided a Google search API. Okay,
Okay.
and you would give the LLM context that it has access to this Google search API, and in order to use this API, this is how it should frame its request. So all of that will be part of the context that the LLM is given. So when a prompt comes in and the LLM is planning on how to execute this prompt, so then it decides, I have access to this Google search API, so I would need to use this API. I would need to get the results from that API, and then I would need to do some further processing. I would need to select these papers. I would need to, again, read through these papers and provide summaries. All of those would be steps,
Yeah.
in the plan that it comes up with. So, um, when you're designing an agent, you typically give it a goal, like what is its purpose? What is it supposed to be doing? And you provide it with all of the tools that you think are necessary for this agent to do its task.
Okay.
And it also, like I said, should have some kind of memory for it to remember what it's been doing so far, both short term and long term. Short term, because for that particular request you might have multiple steps that need to be considered. It should remember all of that. Long term is it should remember what it's doing in the past as well,
Yeah. Yeah.
right? So it's a complex system. It's not just prompting the LLM. All of this access to the APIs and stuff need to be given for it to be able to work the way you want it to.
Okay.
And
Okay.
that's one way that you can actually control the behavior, right? You only give it access to what you think it would need to do its task.
Yeah. Yeah. So if we zoom out today, what do you think Gen AI is going to be known for in, let's say, probably the next 5 years? But it's not talked enough like right now.
Um, okay, maybe not 5 years down the line. I honestly don't know when this would happen.
Okay.
But right now, I don't know if people realize this, but they think that these LLMs can actually reason. Okay, it appears that way, but that's not the truth.
Okay.
What these LLMs are generating are just, permutations of the training data that they've seen. So essentially, they've seen so much data that they're able to pull out patterns from it and then generate based on that.
Okay.
So it's not actual reasoning the way we humans do it. It's more like probabilistically picking out the most likely text or image or whatever you're asking it to generate. But they seem so smart that people actually think that they can reason, which is actually not true. Even the reasoning version of these models, they're actually trained on data like that.
Okay.
Given this scenario, how do I respond to it, or how would I reason this out? So they're actually trained on problems separately like that, so that they're able to somewhat it seems like a semblance of reasoning,
Okay.
but again, it's not. It's just got a bunch of data where it's seeing how people are reasoning,
Yeah.
and it's attempting to
Mimic
imitate
that.
that.
Okay.
Okay, so it's not true reasoning per se. So there is research going on about how. So this is, I would say, the first version of LLMs. I believe that the next version. So you can keep making things better by, just increasing the size, but that's just the first generation, I would feel.
Okay.
I feel. So the next generation of LLMs will probably, there is research going on about how to, include reasoning, or how to make LLMs actually reason. So, given the current model, that is not possible. They've got to find a new way in which to do this, to
Okay.
actually make the model reason in a very human like way. And yeah, that is what I'm looking forward to in the next few years, the next generation of LLMs.
Okay. Okay. So,
But yeah, I don't know how long that is going to take. Maybe 5, maybe 10, maybe more.
but do you think people are thinking about that problem today?
They are. There is research, but yeah, it's very. There are just a few papers. It's a very nascent stage.
Okay. Okay. Done. So, what do you feel is one niche that, is dying for innovation or some sort of product in the AI space?
I think right now, what would be really, really useful is an end to end debugging and logging tool
Okay.
for LLMs. So, as I explained during the whole training process, there is a lot of logging to be done. There is a lot of debugging to be done. And
Mm-hmm.
right now, there are tools which do that, but they're not end to end. Their functionalities differ. Some of them just do part of it. Like, for example, tracking your prompts, seeing which prompt worked better. So there is a tool that just does that. So there is a different tool that is tracking your training loss instability. Okay. So these tools are all fragmented right now. And I feel that it would be a game changer. It would make things a lot easier if we just had one tool that could do all of this through the entire, not just the training pipeline, even after an LLM is deployed into production, to constantly monitor. And especially when you have different iterations of the model, to make sure that the performance is indeed, becoming better and not degrading.
Yeah.
So an end-to-end tool to do that, I think, would be really, really useful right now.
Okay. Okay. So this would be included within the product itself. As in, if I'm, let's say, generating something, I mean, building something today, so I would have to add that into my code or.
Yeah, that should be part of your entire data pipeline. It
Okay.
should have
Okay.
access to the whole pipeline in order to monitor all of this. And even after you put it into production, this tool would still need access to the model to keep logging various aspects.
Okay. Okay. That seems interesting. Done. Perfect. Any final thoughts about what generative AI can do?
Given all of the hype that is happening, I'm pretty sure most people know already, like the capabilities. But right now, I feel like it's more in the B2C space where you see a lot of usage.
Right.
Um, I think in the future, definitely the enterprise is going to catch up, and we're going to have, I think, a lot more models trained for specific domains, maybe.
Okay.
or like you could have like a foundational model for the legal domain, a foundational model for financial data, rather than these general purpose LLMs. Um, a foundational model for cybersecurity. I think there's already one that has come out
Okay,
for just
okay.
cybersecurity. So yeah, as these models become more specialized in a particular domain, I think the enterprise adoption will go up.
Right.
Um, and of course, there are a lot of issues to consider: privacy, the infrastructure running all of this. Um, but I think in the coming years, it should be, I mean, we should be able to um, get past all that.
Yeah. Yeah. Looking forward to that time as well. Down. It was a pleasure having you on the show, Malini.
Thank you so much for having me.
And I hope to call you on another episode as well. Talking
Sure.
probably about something else or probably the second level of generative AI. We'll see. We'll see.
Thank
Thank you.
you.